Today we are solving equations with variables on both sides. Okay, remember when you are solving equations, we want to isolate the variable. Okay, this will allow you to see what that variable is equal to. Okay, so let's take a look here at this first problem. Okay, so we are going to combine our like terms first. Now notice we have an equal sign here in the middle. So when we are combining like terms from one side of the equal sign to the other, we need to use inverse operations in order to keep our equations balanced. Okay, in this case, I'm going to subtract 3 from this side and 3 from the right side. Okay, positive 3 minus 3 cancels out and is 0. So that leaves me with 2x on one side equals x. And then 8 minus 3 leaves me with x plus 5. Okay, then I need my variables to be on the same side. So in order to keep the variables on one side and my constants on the other, I am going to subtract x here from both sides. Okay, then x minus x is 0. So I'm left with 5 equals, and then 2x minus x, remember this is 1x. Okay, 2x minus 1x is just 1x. So I get x equals 5. Okay, and we can see here that A would be our solution. You can also check this into your original equation. So you would have 2 times 5 plus 3 equals 5 plus 8. Okay, 2 times 5 is 10 plus 3, and then 5 plus 8 is 13. 10 plus 3 is 13. So these things are equal. So it is correct. Okay, we always want to check our solutions. Okay, so down here in the second one, I'm going to combine my y's first here. The first one, I combined my constants first. Either way you do it is fine as long as before you start solving for x, everything is combined on one side or the other. Okay, so I am going to subtract y here on both sides. I chose to subtract y because if I subtract 3, that would give me some negatives over here. So I chose to subtract the smaller of the two. So y minus y is 0. That leaves me with 6 on that side of my equal sign. Then 3y minus y is 2y minus 2 equals 6. Okay, now again, I'm going to leave the variable on one side. I'm going to move my constants to the other. So I'm adding 2 here plus 2. That leaves me with 2y equals 8. Okay, then I need to solve for y here. I'm going to divide by 2 on both sides. Opposite of multiplication is division. So 2 divided by 2 is 1. That leaves me with 1y or y. And then 8 divided by 2 is 4. So y equals 4. Okay, then I'm going to substitute this back into my original equation and make sure that this is accurate. So I have 3y minus 2. So I have 3y, which is 4, minus 2 equals 4 plus 6. 4 times 3 is 12 minus 2 equals 10. 12 minus 2 is 10 equals 10. This is correct. So let's go check our answer choices. Now, our answer choices don't actually just have y. They have this step right here, 2y equals 8. So we're going to select A here, 2y equals 8. Okay, so notice you can solve for y whether you combine your y's first or your constants first. All right, and there's one more example here. I'll let you try that one on your own. This one includes distributive property, okay? Several ways that you can do this. I'm going to distribute first in order to expand everything and then simplify from there. So distributive property says I multiply by everything inside my parentheses. So I would get 4x minus 8 equals 3x plus 5. Then from here, I'm just doing the same steps as I did in previous steps. So here, I'm going to subtract 3x. Again, I chose to subtract 3x because that is smaller than 4x. All right, 4x minus 3x is x. I bring down my 8. That becomes 0. I bring down my 5. Okay. Then I'm going to add 8 to both sides. Okay. That's going to leave me with x equals 13. Okay, and you can see here that B is my correct answer. Again, I would go back and substitute this in and check my solution there. Next one has two distributive properties. Okay, you're going to follow the same exact steps. You're just going to do it two times, so once on each side. I'll let you try that one on your own. Let's come down and take a look at this one that has some fractions involved. Okay, for this, I'm going to recommend that we combine our constants first. Okay, and I'm going to subtract 3 from both sides. And see here, that actually gives me a negative. So what I should really do here is subtract 2. Okay, and I'm going to do that to make it simpler. So I have x over 2. 3 minus 2 is 1 equals x over 3. Okay, then in order to move this to the other side, I'm going to subtract it, x over 2, because I'm moving the entire thing. So then I'm subtracting x over 2. Okay, this leaves me with 1 equals x over 3 minus x over 2. Now, when you add and subtract fractions, you need to find a common denominator. Okay, another way you could write this would be 1 equals 1/3 x minus 1/2 x. Okay, either way you write that, totally fine. Either way, we need to find common denominators. The number that both 2 and 3 go into would be 6. So I can have 1 equals, and then 3 times 2 is 6. So I'm going to have 2x over 6 minus, and then 2 times 3 is 6. So I'm going to have 3x because 3 times x is 3x. Okay, and I am left with 1 equals, denominator is 6, and then I have 2x minus 3x. And that is going to give me negative 1x or negative x. So now I have 1 equals negative 1/6 x, or 1 equals negative x over 6. From here, okay, I can do this one of two ways. Well, negative, or x is being divided by negative 6, so I can multiply by negative 6 because I'm doing the opposite operation, inverse operations. These are going to cancel and be 1. Okay, but then I have to multiply by negative 6 on the other side. So I get negative 6 equals x. Okay, the other option here is I can divide by negative 1/6. Okay, negative 1/6 divided by negative 1/6. Okay, and or I can do 1 divided by negative 1/6. Okay, and then I would do same change flip. So this is going to give me the same exact solution, negative 6 equals x. Okay, either way you do it is totally fine. Okay, and then there's one more example that you can work down here at the bottom. This is solving equations with variables on both sides.